Right, so number 8. Unfortunately, I'm going to have to do these in sections. I'm getting a little bit of technical difficulties. Thank you guys for bearing with me. Number 8 says we have a quadratic function defined as follows. They want to put this quadratic function in this particular form, which is the completed square form. Now, I know there are formulas to find h and k. I'm going to do it algebraically, but either way is fine. So we have, I'll rewrite it as minus 2x squared plus 4x plus 5. Go ahead and pull out a 2. We would then have x squared minus 2x minus 5 over 2. Right, we then form the perfect square over this particular quadratic. The perfect square is going to be x minus 1 all squared. And when we expand this, what do we get? We get x squared minus 2x plus 1. Now, this and this has to be the same thing. Now, what do I have to do to this equation here to make it look like this? Well, I have to add or minus something to plus 1 to get this minus 5 on 2. So what do I have to add or minus the plus 1 to get this minus 5 on 2? So 1 plus some number is supposed to give me minus 5 over 2. That number is going to be minus 5 over 2 minus 1, or minus 2 over 2. That's going to be minus 7 over 2. Okay, so we could update that now. We see that k is minus 7 over 2. K is going to be minus 7 over 2. We would then have minus 2 into x minus 1 all squared minus 7 over 2. Right, we could go ahead and get the 7 over 2 out of the bracket by multiplying by minus 2. That would then give us minus 2 into x minus 1 all squared, and then minus 2 by minus 7 over 2. That would give me plus 7. So this here would be the completed square form. We could expand the completed square to ensure we get back our original equation. So that's minus 2 into x squared minus 2x plus 1 plus 7. That's minus 2x squared plus 4x minus 2 plus 7. And when we resolve this, we get minus 2x squared plus 4x plus 5, which was indeed the equation that we started with. Right, so this is the completed square form. So moving right along, we have a table of values for the function. They want us to insert the missing value. So we want to find f of 1 and f of 3. So f of 1 would be 5 plus 4 by 1 minus 2 by 1 squared. That's going to be 5 plus 4 minus 2. That's going to be 5 plus 4 is 9. 9 minus 2 is going to be 7. Then we want to find f of 3. So that would be 5 plus 12. 3 squared is 9. 9 by minus 2, that's minus 18. So we have 17 minus 18. This is going to be minus 1. Right, so now they say using a scale of 2 cm to 1 unit on the x and 1 cm to 2 units on the y, plot this graph on page 27. Okay, so this page is upside down. And that's okay, we'll work with this. Right, so let's get our ruler. I will draw this in a distinct color. Let's do right here. So this would be my x-axis. So here is my y-axis. And here will be my origin. So here is my x. Now the paper itself printed kind of bent. That's why the lines aren't perfectly lined up. Right, so let's go ahead and mark in the axes. We know that the x is 2 cm to 1 unit. So that's 1, 2, 3, 4. Then we have minus 1, minus 2, minus 3. Then on the y-axis, we have 1 cm to 2 units. So that's going to be 2, 4, 6, 8, 10, 12. Minus 2, minus 4, minus 6, minus 8, minus 10, minus 12. Right, let's mark in our scale. So scale x would be 2 cm to 1 unit, and the y would be 1 cm to 2 units. Right, so now that we have our scale, we have our axes marked, let's mark in some points. So the first point is going to be minus 2 on the x, 11 on the y. So that's going to be, I'll use this blue here. So minus 2 on the x, minus 11 on the y. That's minus 2 minus 11 would be right at this point here. Then we have, get rid of this ruler. Then we have minus 1, minus 1. So let's plot minus 1, minus 1. It's minus 1 on the x, minus 1 on the y. And go in again. We have 0 on the x, 5 on the y. So 0 on x, 5 on y. Then we have 1 on the x, 7 on the y. So that's 1 on x, 7 on y. Then we have 2 on the x, 5 on the y. So that's 2 on x, 5 on y. Then we have 3 on the x, minus 1 on y. So we have 3 on x, minus 1 on y. And lastly we have 4 on the x, minus 11 on y. 4 on x, minus 11 on y. Okay, so now we connect these points with a smooth curve. What I usually do, I draw a line here at my maximum point, so it would be easy to connect both halves. Then we pull a smooth line, as smooth of a line as we could, through all of the points. So something that's not perfect. Let's see if I could get it actually through the points. Right, so something to this effect, right? I'm going to do the same thing on the other side. A smooth line through the points. Right, and that there would be our sketch of the graph. I could remove this scratch that I have here, right? So that would be my graph. Then they want us to draw an appropriate line on your graph and use it to determine the estimates of the solution of this particular equation. So we need to set this graph that we just drew. This is the graph that we just drew. We need to set this graph equal to 3. Or another way of reading this is, where does this graph equal to 3? So let's draw a line. Let's draw a line at y equal to 3. Let's draw that line. Right, and now is a case of reading off the values. So let's see if we could get a close approximation. Right, so we have this point here seems to be around minus 0.4 and 3. So this point here is minus 0.4. This point here is minus 0.4 and 3. This point right here is going to be, that's 2, it's 2.5. This seems to be 2.4 and 3. Right, so the x values that equate to the line y is equal to 3, or the x values at which the graph is going to give 3 are going to be 2.4 and minus 0.4. Right, so we have x1, x2. The two x values would be minus 0.4 and 2.4. Question 9, we have a diagram below showing quadrilaterals H, P, and N. Quadrilaterals N and P are the images of quadrilateral H after it has undergone two different transformations. Part A wants us to fully describe the single transformation that maps quadrilateral H onto quadrilateral N. Right, so H onto N. Right, so looking at this, we could see that this is not a flip on the x or y. This is not a flip in the line y is equal to x, neither the line y is equal to minus x. This is some sort of rotation. Right, and if we look at related points, if we look at translated points, this point here becomes this point here. And it seems to me like these 2 points rotated about the origin. So let's draw 2 lines to the origin. Yeah, so we then take our protractor and measure what that angle is. But this pretty much seems like a 90-degree rotation. Let's do 2 other points to ensure that it has. Let's measure this one first. Then we'll do 2 other points to ensure the same angle. Right, so let's see. How much do I have to turn here? I start at this point here. And this might be perfect, but we'll get a good average. So that seems to be 90 degrees. So let's do 2 other points to ensure it's the same center of rotation and the same angle of rotation. So let's do this point here. And this point was translated onto this tip here, was translated onto this point here. Yeah, and well, that's pretty self-evident. When we take the protractor, this would indeed be 90 degrees. So what we have here is a rotation, an anti-clockwise rotation, because we're going in this direction, about the origin of 90 degrees. Right, so the first transformation is an anti-clockwise rotation with center 0, 0 of 90 degrees. Part 2 wants to know the transformation which sends H onto P. Right, so this here is going to be a translation. This point here shifted down. How many spaces? 1, 2, 3, 4, 5. Wrong point. That's 1, 2, 3, 4, 5. 1, 2. So we move. Let me start with the x movement first. So that's this point here to this point here. We move 1, 2 on the x. Then we move 1, 2, 3, 4. Minus 5 on the y. Let's check one other point. So let's check this point here. So we move 1, 2 on the x. 1, 2, 3, 4, 5. That's minus 5 on the y. Right, so that transformation is a translation of 2 on the x minus 5 on y. Part B says on the grid on page 28, draw the image of quadrilateral H after it undergoes the following transformations. First is an enlargement with scale factor of 2 above the center 0 minus 1, and they want us to label this image M. Right, so let's get the center for rotation. That's 0 on the x, minus 1 on y. That's going to be at this point. That is going to be at this point here. Right, and then we go ahead and run a line from our center straight out. right? Right. Right, and lastly, okay, now the image would be the same distance away from, so this distance from the center to this point would be the same distance from our object point to our image point. So let's deduce that using our protractor. So we would maintain the length. Let's do that. So we see, put the center there. Right, so our arc needs to be the same distance away. Right, so we see that the image, I'll do this in blue. Our first image point will be right here. Our second image point. So it has to be the same distance away. Right, let's do this third point right here. Right, so it has to be the same distance away. And lastly, let's check this point right here. Good. And the reason it's going to be the same distance away is because it's an enlargement factor of 2. Meaning we're going to multiply, we're going to have twice this original length. So let's draw now the image. We'll connect the points together. Okay. Right, and that will be our image. Let me get it a bit more clearly. Right, so I hope you guys could see that there. Right, so this here would be our image. We were required to name it what again? We were required to name the image M. Right, so this blue shape here would be our image M. It has a scale factor of 2, and we could see that in the lengths of the sides. So this length here was 2, this length is 1, 2, 3, 4. The base here was 1, the base here is now 2, and so on and so forth. Right, so next they want us to reflect in the line y is equal to minus x, and they want us to label this image L. Okay, so I want to erase these lines here. Right, so we want to reflect now in the line y is equal to minus x. There's going to be this line right here. Right, and reflecting in lines are a bit more straightforward. What we do is we count the same distance to the line and away from the line for the image. So here's how we do that. Our first point is going to be 1, 2, 3 units away. So our second point would also be 1, 2, 3 units away. At this point here is 1, 2, 1, 2, 3 units. So we go 1, 2, 3 units away. Then this point is 1, 2, 3, 4, 5. So we go 1, 2, 3, 4, 5. Right, and lastly, this point is 1, 2, 3, 4, 5. So we go 1, 2, 3, 4, 5. Okay, so now we could connect those points together. Another way we could have done this, if we remember the actual matrix transformations, like what is the matrix for the transformation flipping the line y is equal to x, that's going to be 0, minus 1, minus 1, 0. We'll examine it after to see how we could have used that as well to determine the position of the points. Right, so let's first label this image. We are supposed to label this image L. Right, so this image here is going to be L. Right, so the translation vector is going to be 0, minus 1, minus 1, 0. So what we see here in the first column, the x and y are going to flip positions and the sign is going to change. So let's see if that's the case. So this point here, 3, 3, 0. This went 2, we flip them. So instead of x being 3, y is now 3, and we change the sign. This point here, this is 4 on the x, 1 on the y. This became 4 minus 4 on the y, minus 1 on the x. So we flip the positions and we change signs. Let's confirm that. So this point here is 2, 3. We expect this to be minus 2 on the y, minus 3 on x. So let's see. Minus 3 on x. Let's check that one more time. So it's to be, right, so this is going to be 2 on y, minus 2 on y. And did I miss this point? I think I messed up one. Give me 1 second. Okay, I was looking at the wrong point. So this point here, it goes from being minus 2 on the x to being minus 2 on y. And it goes from being minus 3 on y to being minus 3 on x. This point here is minus 2 on x, 1 on y. So this is going to become minus 2 on y and minus 1 on x, right? So we confirm that this is indeed our image. Right, part C, the diagram below shows 3 pillars, L, M, and N, that are located on ground level. MN is 12 kilometers and LN is 15 kilometers. L is due west of N. L is west of N, yeah. The bearing of M, so we're starting at M. The bearing of M from N, so we're starting at N. The bearing of M from N is 291 degrees. So if we are starting at N and turning to face M, this is going to be 291 degrees. Right, I'm sure we'll need this information at some point in time. Right? The first thing they want us to do is to calculate angle MNL. So that's MNL. They want this angle on the corner here. Right, so because they told us L is due west of N, we know that this angle here, this would be a right angle because these lines would be perpendicular. These are cardinal points. L is due west of N, so we show that this angle here is going to be 90 degrees. Right, so if we know that this here is 90, we could then take this angle here and we can minus 270 from it, because we know that this point to this point is 270. Therefore, this here would make up the rest of this 291. So 291 minus 270. Write that more proper. So 291, 270. That's gonna give us. I don't even need to take one. Right, so that's 1, that's 2, that's going to be 21 degrees. And so this angle on the inside here, this is going to be 21 degrees. Then they want us to find the length of LM. They want us to find LM. Right, so this is a non-right angle triangle. Our techniques for non-right angle triangles would be not SOHCAHTOA or Pythagoras, but either sine rule or cosine rule. Since we have two angles, we could go ahead and use the sine rule. So the unknown length, we would call that x. So we say that x divided by sine of the angle opposite to it, that's going to be 21. X over sine 21 would be equal to 15 over the sine of the angle opposite to 15, which is 110. Right, so x would then be 15 over sine 110 multiplied by the sine of 21. Working this out on the calculator, we get that's around 5.72 kilometers. Right, moving right along. Question 10. The diagram below shows a scalene triangle OPQ with vectors OP is equal to U, OQ is equal to 2V. T is the point that divides PQ into 3 to 2. They want a simplified expression in terms of U and V for P to Q. So to go from P to Q, we could go from, well, before that, let's identify what these sections here would be. We see is divided, PT is 3, QT is 2. So PT would be 3 out of 5 of PQ, and QT would be 2 out of 5 of PQ. Right, so vector PQ would then be, we go from P to O, then O to Q. So that's minus U plus 2V or 2V minus U. Right, we want then O to T. So to go from O to T, we go from O to P, then P to T. That's going to be O to P, then P to T. O to P, that's going to be U. P to T is going to be 3/5 PQ, and PQ was 2V minus U. So that's going to be U plus 6 over 5V minus 3 over 5U. Right, so resolving this now, we have 1U minus 3/5 U. That's going to be 2/5 U plus 6/5 V. We can neaten this up by pulling out a 1/5 to the front, and we would have 2U plus 6. Actually, I could pull out a 2/5 to the front, and I would then have U plus 3V. Part B wants us to write down the 2 by 2 matrices that represents the following transformations: an enlargement with center 0 and scale factor 8. Well, that would be this matrix right here. We have 0, 8, 0, 8, 0. A reflection in the x-axis, so that means that the y value is going to flip. So we're going to have 1, 0, 0, minus 1. Part C, an enlargement with center 0, 0, 0, and scale factor 8, followed by a reflection in the x-axis. Alright, so first we're going to have the enlargement with center 0, 0, and scale factor 8. That's 0, 8, 0, 8, 8, 0. and after that we're going to apply the flip in the x-axis. Right, so let's go ahead and find this matrix product. We're going to have row by column, so that's 1 by 0 is 0, then 0 by 8, that's also 0. Then we have row by column, so 1 by 8 is 8 plus 0, that's 8. Then we have row by column, so 0 by 0 is 0, minus 1 by 8, that's minus 8. Then we have row by column, so 0 by 8 is 0, minus 1 by 0, that's also 0. So this would be the matrix which reflects that. Part 3, the matrices R and Q are expressed in terms of the constants K and C as follows. We have R and Q 6, 1, 4, 2, and Q is K1, C minus 6. They want to calculate in terms of K and C the matrix product RQ. So let's get that. That's 6, 1, 4, 2. Multiplied by K1 C minus 6. Right, so we have row by column, so that's 6 by K, that's 6K plus C. Then again we have row by column, so that's going to be 6 by 1 is 6 plus minus 6, that's going to be 0. Then we have row by column, so that's 4 by K plus 2 by C, 4K plus 2C. Then we have 4 by 2, that's 4, plus 2 by 6, that's minus 12. Minus 12 plus 4, that's minus 8. Right, B says the matrix RQ represents the transformation of an enlargement with center 0 and scale factor of 8, followed by a reflection in the x-axis. They want us to determine the values of K and C. So we need to compare this vector here to the vector that we had before. So we have 6K plus C, we have 4K plus 2C, we have 0, we have minus 8, and we are comparing this to our previous matrix, which was 0, 8, minus 8, 0. This is 0, 8, minus 8, 0. Right, so comparing constituent parts. Right, so I may have made an error because we're seeing here that minus 8 equates to 0 and 0 equates to 8. Something might be off there. Okay, I spotted the error. The error took place because the original enlargement vector would be 8008. So that's my bad. So that means that this here would be 8008, and this here would be 800 minus 8, which makes a lot more sense. Right, so we have then 800 minus 8, and yes, these do indeed line up. Right, so let's compare now. We see that 6K plus C is equal to 8, and then 4K plus 2C is equal to 0. So we see then that if we use this particular equation here, we see that 4K would be equal to minus 2C, and C then would be minus 2K. Right, so we could take this now and solve this equation here. So wherever we see C, we're going to write minus 2K. So 6K plus minus, I could just say 6K minus 2K is equal to 8. Therefore, 4K is equal to 8. Therefore, K would be 2. Right, and if we know that K is 2 and that C is minus 2K, then C must be minus 2 by 2, which is minus 4. Therefore, K is going to be 2 and C is going to be minus 4.